Hello and welcome to a video by Pedantic Planner. I'm going to be starting a KSP playthrough. I don't expect any real eyes on this, but I do enjoy the game, and I find that recording and presenting and talking through some of the design processes help me further organize my thoughts. And I really just, for this series, want to have a high effort, slow, paced out, semi-realistic within the bounds of Kerbal Space Program attempt at a career save. I've got quite a few mods installed. I can leave a list below if anyone displays any interest, but for now, let's just go ahead and get started when we get to the main menu. And here we are in the main menu as the frame rate does its best to catch up. Go ahead and start a new game. We'll call this just the title will be my username. The retro catches my eye there. I like the look of that. Difficulty options. We've got a few things here, and at this point I'll talk about some of the more game-changing mods. First off, we will allow other launch sites because of essentially, if you didn't know about orbital mechanics, when you launch from an equatorial orbit, which is or the equator I should say, where the KSC is normally located, you can achieve any desired inclination with your orbit. That is, you could burn towards the North Pole and immediately hit a polar orbit, or you could end up with an inclination of 0 in a perfectly equatorial orbit. If you start at some other latitude, you can achieve only orbits with as low of an inclination as that latitude from your first launch. If you'd like to go to an equatorial orbit from, let's say, a 30-degree inclination launch site, you'd have to do a plane change maneuver, and those can be quite expensive in terms of delta V. So the other launch sites will be used sometimes, but not every time. But it adds an extra layer of realism that I find can be cool to kind of, world build and narrate. In our advanced, we're going to definitely have part pressure and G-force limits for our Kerbals. I want to say keep things somewhat realistic and not have, 60 Gs on ascent or pulling these crazy maneuvers. Plasma blackout. If you've seen Apollo 13, the movie, you know about this because of their reentry. The extreme amount of electromagnetic radiation generated by the adiabatic compression of the atmosphere leads to basically broad spectrum jamming, and it usually takes away your communications. I'm not going to bother with signal for control because we will have remote tech installed for this playthrough, which will automatically have that active. We're going to always allow action groups. I find that having to accumulate several million funds to level up the VAB and the aircraft hangar before you can use these is just unnecessarily restrictive. I have a bunch of contract packs to give us some micro goals to target, and they also allow for accumulation of funds. We're doing some cool stuff, so it'll give us some variety in our missions. It's not always necessarily go to the next planet or the next moon or the next big landing. It can be more like infrastructural development or establishing space tourism, for instance. Deep freeze. I'm using USI life support and all of the relevant mods for that, as well as Nirtia's near and far future suite, which means that getting to the outer solar system with a manned mission will not be easy in terms of life support. Further complicating this is the signal delay added by remote tech to simulate speed of light, which means that if we want to send an interplanetary probe, we're going to have real issues controlling anything. KOS is an option. I've got that, which allows me to program automated landings and descents a la Curiosity or Pathfinder, or any of these Mars landings you've done in the real life. But deep freeze is maybe a possible thing we could do in the future. I mean, Kerbals are not humans; they have different biology. It's possible that we could cryogenically freeze these Kerbals en route to the outer solar system. It'll just alleviate somewhat their requirements of life support for far exploration missions without a really built-up infrastructure network. However, this doesn't solve every problem, and it's quite deep in the tech tree. And that should do it. With our settings complete, we can go ahead and hit start and begin to get this space program off the ground. Welcome to the Space Center. We have quite a bird problem. There we go. The birds have been escorted off the premises through bribery of breadcrumbs. Remote tech. I like this mod. It's a very cool mod and adds a lot of infrastructure requirements before you can start to go extraplanetary. Essentially, it's going to have antennas that function either omnidirectionally or as a dish. Omnidirectional antennas and have a pretty limited range compared to some of the deeper directed beam, but they also are omnidirectional, so you need not worry about where your spacecraft is pointing. Signal delay, it will be enabled, and we'll use the standard settings for everything. With the one caveat that multiple omnidirectional antennas work on the same craft together. This antenna multiplier, we're going to go with half. Now, my headcanon for this is that in real life, if you have multiple antennas that cannot move and act essentially as omnidirectional point sources of radio frequency radiation, they can be carefully controlled via signal delay, and you can essentially create a phased array of antennas, which gives you some limited beamforming. Now, this won't actually simulate in the game. I'm not going to be able to turn these into directional antennas, but it will somewhat account for the fact that multiple antennae can work together to achieve a similar effect. Also, ground stations are hidden behind bodies. This comes into effect a lot with, for instance, moon landings. If it's tidally locked, you won't be able to control a craft on the far side of the moon without some sort of relay. And ground stations are hidden at defined distances. That's just cleaning up the UI clutter. So this is one I do change. I like to keep no connection needed to control antennas, because realistically, most spacecraft have some sort of redundant internal, almost think of it as a kernel or a BIOS, where they've got some subroutine that loops and says, hey, if I don't have a connection, I'm going to attempt to regain a connection. Another big mod we're playing with is Strategia. If you've never played with this, it really revamps the whole strategy of how your missions go. You can see that there's a bunch of different programs. And basically what we'll be doing is selecting one of these programs, probably split over 1 or 2 episodes each. And we'll talk more about these as they become relevant. We're not going to go through the whole entirety of it to start. What we will go to start is mission control and see what Gene Kerman has for us. And to start every KSP playthrough, unless you're like Strauss and Blitz, or I think it was Bradley Wistons did the entire game in 2 launches. What a maniac. We're going to go with a suborbital trajectory, because I think that may be accomplishable on our very first launch. Thank you, Werner von Kerman. I will not be needing assistance for this launch.
You sure about that? You sure about that?
But we will definitely be using the flea. Now, interestingly, you can actually stack these up. We don't have the couplers yet, but when the second one is activated, it can actually burn through and, in a sense, stage the first booster. We're going to try to see, I think 3 would be able to get us to our first goal of suborbital hop. Color our command pod to be a little more aesthetically pleasing. All right. This is the Mark 1 hopper. To boldly go. Before we launch this, we should consider some additional things. First of which is our stability. Now, I want to be launching Jebediah Kerman on this, so we'll have our control, at least some sort of a SAS ability. But if you look at the center of mass of this craft, it sits roughly here. And as these stages go, it's going to move up and up. Now, with a spacecraft, if you've ever balanced a broom on your hand, you understand the concept that the higher the center of mass is above your center of thrust, the easier it's going to be to make steering adjustments to this rocket. Now, the only actual control authority we have is the gimbal on the boosters themselves and the reaction wheels in the cockpit. If you look at this blue sphere, this is the center of pressure, or basically the sum of all forces aerodynamically that are acting on this rocket. Our playthrough is playing with Ferrum Aerospace, which instead of the stock KSP aerodynamic model, tries to use a voxel simulation and calculate things in a somewhat more realistic manner. What this does mean is that any sort of aerodynamic instability will absolutely be brutal. So what we need to do is get the center of pressure below the center of mass. If this center of thrust is closer to the center of mass, you're going to want it farther back, and vice versa, just because the controllability or the authority we have to move this rocket is directly proportional to the distance between the center of mass and center of thrust. The farther back that this blue center of pressure is from our center of mass, the more passively stable the craft will be. So we want to make sure that if we have low passive stability, we have high active stability. And if we have high passive stability, we don't need as much active stability. So let's throw some fins on. You can see if I add 4 fins radially around this part, the center of pressure jumps down quite dramatically. You see it's not very far behind the center of mass, but that's okay because what we have to consider next is that as soon as this booster is detached, our center of pressure will immediately, again, jump up to the top of the rocket, which means that as soon as this stage burns off, we're going to flip over essentially immediately. So what we need to do is make sure that at every stage that's in atmosphere, and for this will be all of them, that our center of pressure is adjusted accordingly. This is fine, not ideal, but fine. You might be wondering why I'm not adding fins on this third stage. The problem is if I add fins on the third stage, then my first stage starts to lose pressure, and the first stage is really the one I have to be most controllable of, because as the atmosphere gets thinner by this third stage, we're not going to have too many issues with aerodynamic effects. Lastly, we're going to consider our thrust-weight ratio. These solid fuel boosters burn quite quickly, and you can see that our first stage thrust-weight ratio is 3.34. We're going to lower our thrust, which will extend our burn time. Now, we'll incur slightly more gravity losses because of this. I think I want around a 2.5, but it will make it a lot less punishing any minor emiss input at the beginning of our flight. So I want to make sure my thrust to weight is at a manageable degree. I'm going to lower it all the way down to 1.5. We'll see how that works. And immediately we're going to start collecting our first scientific reports. The mod I'm going to be using for this is X Science. It helps you, basically tells you where you are, what science you have and haven't completed, and lets you run them from a nice little menu up here instead of having to individually click on each part. The contract is ordered, actually. We have to recover or transmit this data before we launch the vessel into the air. So what we're going to do is actually roll this right on back and recover it. Now that it's been recovered, you can see that we have completed the first part of this contract. Right here, and now we can launch the vessel into the air and complete the contract. And it looks like the overheating is actually a function of the thrust. So this launch may have to go all the way back to the VAB. Well, that was not ideal. So we can either try that again and change the thrust, but I think what we'll do instead is go ahead and research Engineering 101. This will give us a couple of important things, one of which is the thermometer, which will be our second experiment. And that'll allow us to collect even more science per launch. Decouplers will fix our current issue. Some better antennas, including a helical antenna, which is actually, I think, a dish. And basic rocketry, which has better SRBs. We've got 23 science points to spare. I think for this, we're going to go ahead and start with some survivability research. And we're going to rethink this whole situation. Now, I don't think we need to do much besides adding decouplers in between these stages. The hot staging seems to be a function of the thrust of the engine because the bottom one was able to stage, but the top one wasn't. Adding just these parts should allow us to complete our next contract with minimal errors. Now with decouplers. Since we have them, we may as well add in some landing legs for extra style points. Everything looks good. And I can hear my science alert, that little bubbling sound telling me that there is new data to collect. Atmospheric and temperature scan from the launch pad. We might as well attempt a landing, since we did go through the trouble of including these landing legs here. Ooh, this is what I was talking about with that center of pressure. Just enough control authority on this booster to reorient ourselves in our prograde direction. Just not enough juice on that third stage there to effectively reach a suborbital trajectory. But it does put us into the upper atmosphere, giving us the opportunity to take some more scientific readings. Now, with a simple press of the G key, we can deploy our landing gear and maybe cancel out that spin if at all possible. Looks like we're sitting down next to some beautiful trees, and the landing gear just weren't quite enough. That's fine though. Jebediah Kerman doesn't seem any worse for wear. We can go ahead and take that data again from the pods, as well as the crew report, board, and collect it all over again. One recovery later, and back at the KSC with 60 science points to our name. But I think I also want general rocketry. This should get us perhaps all the way into orbit. Let's see what other contracts we could pick up. This T12 decoupler contract is quite appealing. 50,000 credits is nothing to scoff at. In fact, it's so appealing that I think we'll pick it up. We're going to add a heat shield in. This isn't entirely necessary for our desired trajectory, but it adds style points. We're going to be aiming for a water landing this time, so no need for landing legs. We're going to use this utility bay to aerodynamically shield some of our payload. But I think we'll stick with, for the time being, just 2 more mystery goo containers, spaced evenly, as well as a thermometer and barometer. Time to consider how we're going to get this thing onto a suborbital trajectory. Our decoupler here is going to be activated at 70,000 kilometers on a suborbital trajectory. We're going to accomplish this by using the Pug or the Spark. I think the Spark suits our needs. It's kind of interesting that the thrust from this whole thing is considerably only about 20% more in vacuum than this Spark engine. Due to the somewhat dinky look of this, we're going to toggle off the shroud and just have it fleshly mounted to the bottom. You see our thrust to weight ratio is quite small, but our delta V is extremely high for what we're attempting to do. Which means that even though this looks kind of dinky, in actuality, it should work just fine. And to push this whole thing up into that initial orbit, I think we'll go with one of these Space-Y lifters. Wow, those are quite skinny. A procedural SRB should do the job. Now, as it is stated, this thrust-to-weight ratio is absolutely stupendously more than we need. So we're going to aim for a thrust of about 200 kilonewtons, which is still quite a bit. And we'll change the textures to something a little more visually appealing. Stock-alike, that's what we're aiming for. Lastly, let's look at the aerodynamic pressure and center of mass of this thing. We're going to have to fix that massive imbalance with a handful of fins. Scaled up appropriately. And does this engine offer anything in the way of gimbal? It looks like it does, because there's an option for it. So we're going to assume it does, and hopefully not be massively disappointed. This should be able to get us onto a suborbital trajectory. Corsets are all the rage, given the size 0 waistline of this rocket. I think it's a fitting description. And instead of immediately staging, I'm going to coast up to maybe 20,000 meters before activating this next stage. I don't think it has the control authority to keep us straight until we're up here, and you can see there's a bit of wobble. And with that, we are in space. A crew report and a mystery observation will get us started. The cutoff for space high, I don't recall off the top of my head, but I think it's a ways. We'll see if this remaining about 5,500 meters per second delta V will get us up to that required level. And we are nearly at SECO, or second engine cutoff. And that's all the fuel. Now quickly, I'm going to switch to the Space Center with Jebediah Kerman still bravely in flight, and upgrade our astronaut complex, which will allow Jebediah to perform an EVA. I can now rejoin the hopper on its flight, and Jebediah can now EVA. Test complete. This stage will burn up and likely impact the ground, and we can orient a retrograde with the intent of taking a little bit of the aerodynamic heating. Not that it's necessarily super high currently. We should have plenty of science and funds after completing that contract to actually suborbital hop and the testing of the decoupler. 155 science. What a haul. I think we're going to start off with some advanced rocketry, some basic science, one more level, looks like 4 technology is all we can do. Let's see what we can put together in the spaceplane hangar. A mystery observation while flying low. Easy. So we're going to back out and upgrade our mission control, be able to handle more contracts at once. We're going to take all 3 of these focused observational surveys below. Oh, sorry, that's above. Oops. Below, and just give an altitude. Let's look at the tracking station and see where these zones are. Hello again, Gene. Zone 8799, above 17.7 kilometers. I don't think we can get there with our basic jet engine we just unlocked, but with enough rocket boosters, anything's possible. Now, the process of designing a plane, especially with Ferrum Aerospace, is a little more intricate than you may realize. We'll add a tail section on, and wings. Something nice and simple. These B-type connector wings. And they can actually hold fuel as well. We're going to essentially build a skeleton of a plane here and worry about the actual controls in a moment. I'm going to go with a combined tail section that handles both pitch and the rudder control in one go. For landing gear, we have limited options, just the steerable landing gear and the fixed landing gear. I'm going to throw a steerable one on the front and some fixed on the wings here. We have the Juno basic jet engine, which needs to be placed in a stack to start with. And we're going to want some air intakes for those as well. Those will be mounted somewhere on the back of the plane, a la private jet. And now to get into the actual hard part of designing a plane, which is stability. If I pull up my center of mass and center of pressure, you'll notice right away that the center of pressure is far ahead of the center of mass. What this makes the plane want to do is perform a pitch-up maneuver, essentially, immediately after takeoff. If we look at our Ferrum Aerospace GUI here, and sweep at a given speed, in this case Mach 0.2, across an angle of attack from -10 to 25 degrees, it'll pull up a few lines. The green one is your lift-to-drag ratio. Essentially, the local minima or maxima are your most efficient angles of attack for your given wing. The CM is essentially the combined forces acting on the nose of your aircraft. What we want this line to do is be in the positives for the negative angle of attack and the negatives for the positive angles of attack. What that will mean is that the plane passively wants to fly straight and level. Right now, how it is you see, for instance, here at a 15-degree angle of attack, our CM is quite high. What that means is if the plane is pitched up at 15 degrees, the forces acting on the nose are in the positive direction, meaning they want to further pitch the nose of the plane up. This is a function of our center of drag being ahead of our center of, our center of lift being ahead of our center of mass. To fix this, we have a few options. The first of which is altering the center of mass. And the easy way to do that is the fact that I do not need this much liquid fuel. The next thing to do is actually adjust where the center of pressure is. This can be done by changing the wings' location. We put them farther back, the center of pressure will move back. But as you notice, this is starting to look very much not like a typical plane. The reason for this is because the center of mass in KSP is not quite the same as it is in real life in terms of where things are scaled. We're going to remove the liquid fuel from the tail section, bring our center of mass even farther forward, and we're going to increase the size of these rear control surfaces. This has gotten us quite a ways of the way there, but we're still looking a little rough. If we move these jet engines up a little bit, you can see that they're actually quite a significant portion of this center of mass. And instead of putting them on the plane tail, I think they might actually be better suited if they're on the wings of the plane. With that adjustment, we have effectively put our center of mass ahead of our center of lift, and if we recalculate this AOA, you'll see that instead of sloping from bottom to top, the line now slopes from top to bottom, but only barely, because this center of pressure is not very far behind our center of mass. Let's think about some further tweaks that can be done to this aircraft. For instance, we're going to move the wings back just a hair, and the pods just a little farther forward on them. Since we have 3 contracts to complete, I think we can afford actually another liquid fuel section in here. We're going to tuck those in a little closer to the actual plane's center of mass. Perhaps a whole another wing connector here. An important term in aircraft design is the aspect ratio of the aircraft. And what that essentially means is the ratio of the wingspan to the wing chord. The wing chord is this distance from here to here. Essentially the path or the length of the path air will take when it flows over the wing. The wingspan is the distance from the tip of the one wing to the tip of the other. The higher this ratio, that is, the longer your wingspan is relative to your mean chord, the more lift you'll generate. However, it'll perform worse at high speeds. I'm not really trying to take this plane to extremely high speeds, but I am trying to take it far, and so that means efficiency here is probably our best bet. From here, we're going to consider the placement of our landing gear. You don't want your landing gear to be very far from your center of mass, at least your rear landing gear in this kind of configuration. The farther they are from your center of mass, the more authority is required to pitch the nose up off the point of rotation, which is your rear landing gear. And so we want them pretty closely centered on the center of mass. Now with these basic landing gear, it's quite annoying because they're not very good in terms of distance or structure or really anything. So the only way to get them low enough to where we actually sit somewhat ideally on the runway is to bring them all the way down here and give us quite a narrow wheelbase, which means landing this plane will be something of an adventure. From here, we're going to assign our control groups to our elevons. In this case, I want to make sure that these elevons here act as ailerons and only control the roll of my craft. I do this by giving them no pitch or yaw authority and 100% roll authority. And then these in the rear act as both our pitch and our yaw control. So we're going to give those both 100%. In fact, I'm going to take yaw down to maybe half strength because I want a little more give for pitch. Yaw stability, if you look at the stability derivatives, we can calculate this for 0 kilometers at around or sea level, essentially at a relatively slow flying speed. And all the green essentially means that our plane is stable. The hovering over each of these derivatives will tell you essentially what they mean. For instance, this in beta is the change in yaw right angular acceleration with respect to slide slip angle beta should be positive, which means that if we are beginning to slip sideways, if this is our direction of flight and we do this, the aerodynamic forces acting on this tail are going to right the craft and point the nose towards our velocity in the airstream. Lastly, we're going to check our static analysis one more time and see if we have successfully created a passively stable aircraft. It looks like it's essentially stable. It has no real bias towards one or the other, but if you notice over here at a pitch angle of 1 to 15-ish degrees, how the lines diverge, this is our stall angle of attack, meaning that if we pitch this aircraft up much above 15 degrees, we're going to have issues. This is also a function of the Mach number. If you're going faster, you can see that our stall angle actually drops a little bit. And if I were to get this thing up to supersonic speeds, you can see that we encounter another region of stability. And when you enter a supersonic flight, a lot of variables change, and it becomes a completely different ballgame. This plane and the way it's set up right here with this high aspect ratio and relatively passively stable orientation is not in any way optimized for supersonic flight. We will be tackling supersonic flight at a later point in this series, but for now we're going to keep to the just gentle subsonic flight. So, you know, we may have one more option to move our center of mass farther back. We detach this whole section, add a service bay, and reattach, and check where our center of pressure ended up. It looks like that's assisted us in stability. I don't want these parts on the surface because Ferrum Aerospace will treat them as parts with drag, and it will cause some minor instability. We'll put this nice antenna flat surface mounted on the bottom of the airframe, where it should do relatively little in the way of damage to our airstream. And we'll throw in some battery packs for good measure. If you look, my lower landing gear are ever so slightly lower than my front landing gear, and this means on the runway, the plane is going to pitch ever so slightly down until they are level. I could demonstrate this like so. That's about where the plane will want to sit. We want it to sit a little bit up, which means that we're going to need to adjust the position of our landing gear by bringing them up ever so slightly, such that they're at or maybe just a little bit above the front landing gear. If we do want to complete that one contract that asks us to go to a pretty high altitude, we're going to need some sort of jet assistance. Of course, this will impact our flight characteristics somewhat, but it looks like it hasn't affected it too unduly. I think, just given off my experience, this craft is ready to fly, but I may be proven horrifically wrong. We'll call this the Cruiser Mark 1. We're going to upgrade our spaceplane hangar, and the runway itself cannot handle the length, and we're quite low on funds. See if there's anything we can do to maybe get a little bit more money right off the bat. Our runway upgrade will cost somewhere in the order of 75,000 funds. And I think I found our 75,000 funds as an advance for these relay networks. We're going to do the 4 network relay when we eventually get to that, and we're going to go ahead and accept that contract for now. It'll give us the necessary capital in order to upgrade our runway and actually take this cruiser for a spin with Jebediah Kerman as our fearless pilot, as usual. Going to select our first navigational target and demonstrate some of the cool features of atmospheric autopilot, which includes waypoint selection and automatic flight. And as we enter the area, we'll take a simple crew report, which we don't need to keep, and we'll have completed that contract. Our next waypoint will be Teapot's Envy. We'll let the autopilot take us there, and we need to take another crew report. We're in Teapot's Envy. One crew report later, and the contract is complete. Over to zone 879er. To complete this contract, we need to be in the zone above 17.5 kilometers, so 17.7 more precisely. We're going to put the master switch back towards standard flyback wire, pitch up to about 45 degrees, and activate our rocket booster, somewhat torching our control surfaces in the process. Paying close attention to our apoapsis. we'll see if we're able to make it all the way up to 17.7 kilometers. And no, not quite enough oomph in that stage to make this happen.
My disappointment is immeasurable, and my day is ruined.
Now all that's left is to fly this aircraft back to the runway. And quick save at this time, just because landings can be dicey, especially with this bad landing gear. Previous landing attempts have failed due to an excess of speed and the, quite frankly, ridiculously poor performance of the stock landing gear. Which means that on this approach, we're going to do some advanced aerial acrobatics in order to try to bleed off as much speed as possible before final approach, including a very near pass to a large coniferous tree, and a basically at stall speed maneuver towards a landing orientation. And with only a few dozen meters to spare, the plane rolls to a stop. We're going to go into the spaceplane hangar and slightly adjust the fuel values of our craft in order to give it just a little bit more performance. And by that I mean reducing the takeoff fuel as much as possible. We're going to be taking just 1/5 of our typical fuel amounts. With that, Jebediah prepares for his second attempt at completing the focused observational contract above 17.7 kilometers. One issue with this design is that because the center of thrust of this booster is so high off of the center of mass, upon activation, it induces a radical torque which pushes the nose of the aircraft down. The torque is so strong that at this airspeed and altitude, my control surfaces just aren't up to the task of counteracting it. However, there is a solution.
Because I was inverted.
Bullshit. No, he was, man. It was a really great move. He was inverted.
By inverting the wings, I effectively turned that forced pitch down maneuver into a pitch up maneuver by starting at about 20 degrees and counteracting it with my control surfaces. If I time it correctly, I can run out of solid fuel right as my prograde vector crosses straight onto the vertical mark. And it looks like I timed that just about right. With a bit of centripetal force, we're able to detach the booster. However, the airstream keeps it nice and close to us. While not ideal, it's really not that big of a deal, and it drifts away harmlessly in a few seconds. We're in the zone and the target altitude, so we collect the survey data. Hopefully the limited amount of fuel in the aircraft at this time will make the landings a little easier on these horrendously underpowered wheels. While not ideal for the reuse of this airframe, the saying goes that any landing you can walk away from is a good one. And Jebediah Kerman, I think, agrees with that sentiment. Cleaning up the debris, we ponder the completion of our next contract. In this case, we want to be orbiting Kerbin. A very simple orbital spacecraft isn't really that hard to make. However, we're going to take this as an opportunity to complete another contract I spied earlier in the Mission Control Center. I think for this scenario, we're going to go with a basic Sputnik style launch. A lot of the parts in KSP seem to be attempting to recreate real satellites or spacecraft that flew, and the Sputnik is no exception. While not necessary for our goals for this flight, the inclusion of the very, very iconic 4 antennae do add a certain degree of style points that personally I think are worth the extra effort. This craft will be unable to generate electricity while in orbit, so its main purpose will be just to complete contracts. Adding on a fairing, we now turn to the problem of getting this payload into an orbital trajectory. To accomplish that, we're going to use a liquid-fueled upper stage. For the name of efficiency, we're going to want to go with something that has a specific impulse that's quite high in vacuum. In this case, the Terrier liquid fuel engine has a 345-second specific impulse, which is sufficient for our needs. On to the first stage that will propel this upper stage into a suborbital trajectory. We're going to go with a pretty moderately sized solid rocket booster. In this case, the Thumper. It has a total delta V just over 2,000 at its current burn time. In the wiki, or some delta V maps, it says about 4,500 meters per second is required to orbit Kerbin. And I find in my experience that that's about what I need as well. We're cutting it a little close with this launch, but not to the point where I think we're going to struggle. Lastly, because this is an unmanned craft, we're going to need to add in some sort of remote antenna. The reflectotron antenna is sufficient for our needs and will give us control authority over this booster on its ascent. I haven't yet unlocked the structural mounting, so this is going to be launched from the engine itself. However, just this alone, I think, is sufficient to be able to launch our payload into orbit. Out of ideas for today's episode in terms of funny names, I'd simply call this ship Orbiter 1. With our staging checked and correct, we're going to do one last thing before we launch this rocket. And that's pick up that contract I was talking about earlier from the Mission Control Center. That contract is part of the Unmanned Missions contract pack, which asks us to get a probe into orbit. No one ever turned down 47,000 funds. Due to the limited electric charge of the Sputnik, launching is going to be pretty much a requirement to do as soon as we get onto the pad. Furthermore, without MechJeb or something similar, I have to manually fly the rocket with no assistance from SAS of any kind. This is difficult at the initial low speeds, but as we pick up speed in the atmosphere, the aerodynamic stability provided by the fins keeps us oriented in the prograde direction. A shallower ascent profile would be more efficient, but due to the lack of sufficient gimbal on the upper stage or control authority, I want to make sure that my initial burn puts me with the suborbital trajectory that has an apoapsis clear of the atmosphere. This will allow me to deploy the payload and guide this rocket without too much interference from below. Once I cross the 40,000 kilometer mark, I go ahead and detach the first stage. This is high enough out of the atmosphere where the aerodynamic stability of the bearing won't put me too far off course, and I can overcome it just by manually flying and keeping the prograde vector aligned. Our orbital apoapsis is quite high at this point, so I take it upon me to start burning sideways as quickly as possible. As we continue to gain altitude and across about the 65 kilometer mark, I go ahead and deploy the fairing to reduce weight, and aerodynamic drag is no longer much of an issue at this high of an altitude. As the upper stage burns most of its fuel, it becomes quite squirrely when trying to control, so I cut the throttle to half to give me an easier time of manually flying the thing. I'm not aiming for quite as much of an elliptical orbit, but I have to make sure not to leave the Space Center entirely before I finish my burn. I time warp forward about as far as I'm comfortable, and then complete the burn there with the beautiful shot of the sunset over Kerbin in the background. I go ahead and detach the payload, which is just enough to put it into an orbit. For the sake of Sputnik, I go ahead and activate my antennae and take a final look at the first object to enter orbit. With its electrical charge now completely drained, it is essentially space junk. However, it is aesthetically pleasing space junk. With that, I think we'll end our episode here. Thank you for watching, and if you have any questions, let me know in the comments. I don't necessarily know when the next will be out. Perhaps a week's time, perhaps a month's, perhaps the next day. It depends on how well this goes. This is my first video I've ever uploaded to YouTube, and my first foray into editing, so I'm quite new and therefore quite slow with the whole process. But thank you for your time, and have a wonderful day.